Hello everybody, this is Dr. Thunder. Today, I would like to show you how to solve a US high school physics competition problem. So, a juggler juggle n identical balls, catching and tossing one ball at a time. Assume that the juggler requires a minimum time t between ball tosses. So the time between the two adjacent balls, t. And so then we want to decide the minimum possible power required for a juggler to continue juggling is proportional to what? So to solve that question, first let's look at one individual ball here. So assume the ball is tossed at an initial speed of v0, and then it will go up. At some moment it will stop due to the gravity. So assume that's the position that is stopped. So at this moment, V final is 0. So then we want to know the time it takes for the ball to be tossed, and then between the moment that it's tossed and then the moment it stopped in the mid-air. Of course, then it will fall back. So time, as we know the equation, Vf equal to V0 minus Gt. G is the gravity. Because the initial speed has the opposite direction of the gravity, so there's a minus sign here. So this means because Vf is 0, so T is V0 over G. And then it will fall back. So we will get a same results. So now we further define this T is up T. That means it go up, T up, and then there's a T that going down. That means it go up and stop and going down. So the time that it for the ball to go from the highest point to the initial position would be T going down is also V0 over G. So the total time to finish one toss will be T equal to T up plus T down, which is 2V0G. So let's look at any particular ball here. So once it gets tossed, you will take 2V0 over G time to reach the other hand of the juggler. So this means approximately T is equal to, if we have M balls and T. Remember, capital T is the time lag between the two adjacent balls. So we have this relation. Now look at the power. Power is defined as the energy over T. So the juggler, as the problem said, it requires a minimum time, capital T, for the juggler to throw two balls. So the energy E is E will give the ball the initial speed. So E is half mv0 square. This is initial speed. So that's the energy that the juggler gave to each ball at a very starting point. So this is proportional from this equation. This is proportional to t square. So t square from this equation. And we know that t is equal to nt, capital T. So this is further proportional to n square t square. Now, because P, the power is energy over time, so P is the minimum possible power required for the juggler to continue juggling. So P is E over T, because E is proportional to this, so P is proportional to n square t. But in this case, t is rather a constant, so it's proportional to n square. So we clean it up, p is proportional to n square. So this is the final answer. Thank you for viewing. If you like my video, please comment, like, and subscribe.